Okay, so here we can see the tools of the trade. These are a few different styles of drill bits that you can use to drill fastener heads. To the left, the first set, these are high-speed steel bits. On the left is 16th inch and on the right is 3/32. I typically recommend using a 3/32 bit whenever possible. You get down into the 16th inch range and you'll have problems with tool breakage. High-speed steel, really not suitable for drilling almost any material of fastener. Fasteners use hardened metals, very strong, very hard on bits. You really won't get very good tool life out of high-speed steel. The next set, I have a bunch of these. These are the bits I use the most, and they are solid cobalt, 3/32 stub length. You can see they're shorter than some of the other designs. They're shorter than the jobber length high-speed steel that we talked about. The shorter length makes the bit stiffer, so you'll have less problems with walking. You'll have less problems drilling straight holes. I prefer to use stub length drills whenever possible. To their right is the same style bit, solid cobalt, except this is just jobber length. I use these whenever I need to drill a hole that's deeper than you can drill with a stub length. Doesn't come up very often. I don't use them very often. In the center is a solid carbide bit drill, and solid carbide is a lot harder than cobalt. You can get through harder materials with the carbide. However, it's very brittle, so you need to use a lot of care to make sure that when you chuck all of your parts, everything is stiff, your machine is stiff, otherwise you'll have problems chipping or breaking. The good news with the carbide is if it does break, it's very easy to get out of the fastener. Whatever remains inside the hole can be knocked out, broken apart with an awl or a punch or whatever you have on hand. Now these guys are straight flute, stub length, solid carbide bits. The straight flute ones are really nice. They've got a lot more meat to them than the helical flute ones. They are stronger, they're less likely to break, and they also do not walk on the material. However, due to the straight flutes, they don't remove material very well from the hole, so they don't remove chips very well from the hole, so you need to back them out and clean them out frequently. Also, as you can see, the cutting surface is quite short, so you cannot drill very deep. The next one is a center drill. It's hard to see in the video, but it has a very, very small tip. I use these on fasteners where I think I'm going to have a problem with the bit walking, so I'll use these to create a point on the head where the next bit can start easily. And then to the right we have three different kinds of countersinks. This guy and this guy are zero flute countersinks. I use these primarily. This one is high-speed steel. This one is solid cobalt. And they're really nice because they don't chatter, especially with some of these little holes. If your machinery is not very, very stiff, you can have chatter problems with more traditional designs. And the one on the right here is a solid carbide countersink, 4-flute, much more traditional design. They're nice because they come to a point, so you can do very, very small holes. However, I find that, again, unless you have a very, very stiff tooling, you have chatter problems and your countersink finish won't be very good. So why bother countersinking at all? Well, if you drill a good hole, you have a pretty smooth finish, but you still have a bit of a sharp edge at the entrance and exit point. And remember, your lock wire is going to be right on that edge. It's going to be bent around that edge. So I like to knock that edge down with the countersink.